Coding 101 The Kids Way is an educational program which teaches kids ages 7 to 12 years all about coding and how coding impacts their world. The aim of the program is to inspire kids to learn how to code through practical experiences and insights to career opportunities. This outline was developed by Smart Kids Educational Club on behalf of Tambourine Learning for the Public Broadcasting Corporation of Jamaica.
Are you ready? Let's go! Wow! All right! What's up, mini coders? Welcome back to Coding 101 The Kids Way. I'm Cece the Robot. Before we begin today's episode, let's go over the previous week's show where we discussed coding languages and their purposes. Coding involves learning a special language that computers can understand and using that language to write instructions that the computer will follow. Computers use different languages to communicate with programmers. These languages are called coding languages. We compared the different coding languages to human languages, and we spoke with Greg, who's a coder by profession, and he gave us a wide knowledge of it all. The previous week was absolutely amazing. In case you weren't able to catch it, you can find the complete show along with previous episodes on our YouTube channel at PBCJamaica. Now it's time to jump right in. We're about to delve into the exciting world of back-end development. Hey kids, have you ever wondered how the website and apps you use every day actually work? Well, one important part of building these digital creations is called back-end development. Think of back-end development as building the brain of a website or an app. It's all the behind-the-scenes work that makes everything function smoothly. Just like how you have a brain that controls your body, the back end is responsible for making the website or app work correctly. Back-end developers use different programming languages like Python, Java, or Ruby to write the code that powers these websites and apps. They create databases to store all the information needed, like usernames and passwords, messages, or even high scores in games. For example, suppose you're playing a game on your phone. The back-end developers would have created a database to store your progress. So when you want to continue playing later, all your levels and achievements are saved. Back-end developers also handle things like security. They make sure only authorized people can access sensitive information and protect the user's data from hackers. Another important task of back-end developers is making sure everything runs smoothly and efficiently. They optimize the code and databases so websites and apps load quickly and respond to your actions without any delays. To summarize, back-end development is the process of creating the brain behind websites and apps. It involves writing code, creating databases, ensuring security, and making everything run smoothly. So the next time you use a website or play a game on your phone, remember that there's a team of back-end developers working hard behind the scenes to make it all possible. Let's break down the difference between front-end, back-end, and full-stack developers. Think of building a website like building a house. Front-end developers are architects who focus on designing and creating how the house looks from the outside. They work on things like colors, fonts, buttons, and images to make the website look appealing to visitors. They use coding languages like HTML, CSS, and JavaScript to build the visual parts of the website that users see and interact with. On the other hand, back-end developers are like construction workers who work behind the scenes to make sure the house runs smoothly. They handle things like server management, databases, and complex logic. They use programming languages like Python, Ruby, or PHP to write the code that powers the website's functionality. For example, when you submit a form on the website, the back-end developer takes care of saving that information into a database. Now, imagine having a house that is both beautifully designed and functions perfectly. That's where full-stack developers come in. They can do both front-end and back-end development. They have the skills to work on the whole house, from the layout and design to the plumbing and electrical systems. They're like the ultimate house builders who can handle all aspects of building a website. So in summary, front-end developers focus on how the website looks and how users interact with it. Back-end developers handle behind-the-scenes functionality and server management. Full-stack developers can work on both the design and functionality of a website. I hope that helps explain the difference between these three aspects of web developers in a way that makes sense to you, the kids. Overall, back-end development plays a critical role in handling the foundation and functionality of web and mobile applications, ensuring that the server-side component works seamlessly and efficiently to deliver the desired user's experience. Stay with us for more Coding 101, mini coders. We'll be right back. Hello, mini coders. I'm excited to be back with you all. I'm Cece the Robot, and I'm thrilled to be part of Coding 101 the Kids Way. Just a quick reminder, in our previous session, we discussed back-end development and distinctions between back-end, front-end, and full-stack developers. Remember that? Great! Now let's dive deeper into back-end development by introducing our guest, Nimoy Burrows. How are things going, Nimoy?
Hi, CC. Thank you. I'm Nimoy Burrows, and I'm a data engineer / backend developer.
I have some full-stack web development related questions that I would like to ask you. And the mini coders are thrilled to hear from you. What are your thoughts on the future of data-driven development?
Okay, so I think the world is really leaning towards more data-driven development because it allows us to build more systems that are automated and that use data to make decisions quickly and accurately.
What are some of the challenges you faced in your work with data?
So the data that we produce a lot of the times is geared at business professionals, and gathering input from these professionals to provide them with the insights that they need is sometimes challenging because persons are very busy, and it might be difficult to tie them down to get to understand what they need from the data to get the data to produce that.
How do you stay up to date with the latest trends in data science and data engineering?
So I read a lot of blogs, and I watch a lot of YouTube videos around topics that interest me. So I don't just watch everything. And in addition to that, if I find something very interesting, I'll do a course online around that topic or technology. And of course, I'm always experimenting. As soon as I find something that I like, I'll try it out, test it out, see if it works, and then decide if this is something I want to pursue.
What are some of the most important skills for a back-end developer who focuses on data?
One of the major skills that you need to develop is writing scripts or scripting in languages like Python, PHP, Java, and of course, understanding databases and scripting for databases, writing scripts for SQL, MySQL, a little MongoDB, and most importantly, you have to be able to analyze data and be a critical thinker.
Can you tell us about the time when you had to use data to solve a problem?
So recently I've been trying out some things in hydroponics farming, and the container that we use to store the water, it's enclosed and it's dark, so you can't see the water levels in it. So what we've been doing so far is we install a sensor on it to gather water level data and store it, so we can use that same water level data to now trigger the pump, because the pump doesn't work all the time. It only pumps the water into the reservoir or into the container when the water level drops too low. So we've been just gathering data, seeing the level of the water, and we use that to now tell the pump when to turn on and fill it back up.
What are your thoughts on the ethical implications of data use?
Okay, so ultimately, personal data is owned by you, the individual, right? So I think companies should be forthcoming with how they collect data, how they plan to use the data, and of course, giving you, the individual, the option to always opt out, and ensure that whenever you decide to opt out, your data is actually removed from their databases. Because as I said, you own the data, and if you don't want companies to have your data, they should give you the option to opt out. And of course, they should tell you exactly what they'll be doing with the data.
What are some of the most common mistakes you see back-end developers make when working with data?
This one is something I see a lot, sample size selection. So of course, sometimes depending on the size of the data, you may not be able to look at all of it. So you have to select a sample size and analyze that and write scripts around that to kind of gather the insights that you want. But sometimes as developers, we select sample sizes that are too small. So essentially we exclude some of the data that we should be looking at and be scripting around. And of course, now this kind of skews the results that we expect. So for example, let's say you're reviewing the usage of a website, right? And the sample size that you selected only includes teenagers. So you're looking at how teenagers use the website. But if you only select a sample size that includes teenagers, you will never understand how adults use the website. And of course, adults may be the ones spending the most money on the website. So it is important to select a sample size that includes, in this example, both teenagers and adults.
What are some of the best practices for working with data?
You have to ensure that you document everything. It helps to guide others. And of course, sometimes we forget things. So you want to ensure that you have some sort of reference to remind yourself of what you did and why you did it. You have to ensure that you verify the quality and accuracy of the data that you're working with. You should also be checking for outliers and missing values. You don't want to have things that will throw off your insights or your data. And start small. Start with a small data set and then expand, because sometimes it might be overwhelming to work with a big database or a big set of data. So you start small and then you expand until you cover all you need to cover.
Oh, what are your thoughts on the future of big data?
Big data, I think, will provide greater efficiency in all industries, from decision making for governments, I think even fraud detection, especially like in the financial sector, and also even in healthcare, the quality healthcare that you get as individuals. If we use more data, we can provide more accurate delivery of healthcare options.
What are some of the most interesting projects you've worked on with data?
I would have given an example earlier with the hydroponic setup, tracking the water level and using that to trigger the operation of a pump. I've also done a disease detection in plants model. So essentially, we take a lot of images of pepper leaves with a particular disease, and we use these images now to build out a data model. And this data model now, you can use it, for example, in an app, and you scan. If you provide that app to a farmer, the farmer can literally just scan the leaf of the pepper tree, and it will tell the farmer what disease the pepper tree has, and of course now what kind of nutrients or herbicides or pesticides they might need to apply to that tree to make it, look better or get rid of that disease.
What are your thoughts on the role of data in the future of business?
Data will help businesses to make better and smarter decisions. It will also help to keep the business up to date with how customers are interacting with them and what the customers are doing. And of course, I think it will also help them to be more efficient in their operations.
What advice would you give young back-end developers working with data?
Practice, practice, practice. There are a lot of free resources available online. Use them as much as you can to improve your skills, and don't be afraid to just try something. If you're curious, trust me, that will be a great asset to have. Just practice, try things, and don't be afraid to fail. You'll only learn from failures.
So interesting. Thank you, Nemoy, for joining us and sharing your insights on the role and responsibilities of a full-stack back-end web developer. Stay tuned, mini coders. We'll be back shortly with more Coding 101. Don't go anywhere. Hello again to all of you, our mini coders with big dreams. I'm Cece, your trusty robotic instructor for Coding 101. For those who are just joining us, let me catch you up on what you missed. In our previous session, we delved into the world of back-end development. We explored the distinctions between front-end, back-end, and full-stack developers, and had the pleasure of interviewing Nemoy Burrows, an expert back-end data developer who shared various insights and experiences in working with data. Now, we've got some exciting videos from our awesome friends at Treehouse. Let's take a look, mini coders.
In this video, you'll learn what a back-end developer does and what you'll need to learn in order to become one. But first, we need to define what a back-end developer is. There are generally two parts to any web application: the front end, or client side, and the back end, or server side. The front end consists of the web pages you see and interact with in your browser. Those pages are usually designed by front-end developers. But how are those pages delivered to the browser? And when a user enters data into those pages, where does it go? When a user enters a URL, clicks a link, or submits a form, their browser connects to a web server. A web server is just a computer running software that delivers resources like web pages and images. When a web server receives a request for a resource, it needs to respond with that resource. Programming web servers to respond with the correct resources is the domain of back-end developers. Before a web page or other resource is delivered to a browser, a web application written by back-end developers fills that page with data. The data is pulled from a database, which is a separate program that stores and retrieves data. Back-end developers need to understand whatever programming language the web application is written in, as well as the database where the data is stored. So a front-end developer designs web pages, and a back-end developer serves up those web pages, customized with user data. You may have also heard the term full-stack developer before. That just means someone with the skills of both front-end and back-end developers. Web developer is a term that isn't as clearly defined. It could mean a front-end developer, or it could mean a full-stack developer. Back-end developers typically work together with front-end developers when creating a web application. While the front-end developer focuses on the look and feel of a website and the user experience, back-end developers focus on the data the site presents. Most web apps present various forms where users can enter data to create profiles, share stories, keep track of appointments, and so on. Back-end developers are responsible for storing this data and ensuring it's only presented to users who are supposed to have access to it. Many websites require paid subscriptions in order to access them. Some back-end developers are responsible for accepting data on credit cards and other methods of payment, securely storing that info, and making charges to that payment at the right times and in the right amounts. APIs, or Application Programming Interfaces, are resources meant to be accessed not by web browsers, but by mobile phone apps and other programs. There are many steps to responding to a request from a browser, each requiring a different type of software. The combination of technologies used by a particular web server is known as its tech stack. Let's look at each layer of a typical tech stack. When the browser connects to the server, web server software accepts the request. Examples of popular web server software include Apache, Nginx, and Microsoft IIS, short for Internet Information Services. By the way, just as you see several options for web servers, for each layer of the tech stack, you'll find there are many choices between software and frameworks. There's no way to learn them all before you get your first development job, but you'll find that the different web servers, frameworks, and databases all work in much the same way. If you learn a popular language or framework from each layer, you'll find there are plenty of companies ready to hire you and train you in their particular tech stack. The web server software then passes the request off to a web framework. Web frameworks are libraries for programming languages that help back-end developers handle web requests. There are many different programming languages out there, each with multiple frameworks to choose from. But again, they all work similarly, so after you've learned one language and framework, you'll have an easier time learning any of the others. We're showing the most popular languages and their corresponding frameworks here, as those tend to be the ones with the most companies hiring developers. JavaScript is a language originally developed to run inside web browsers to make web pages more interactive. More recently, server software has been released that allows developers to write JavaScript code for the backend as well. Popular JavaScript web frameworks include Node.js and Express. Java should not be confused with JavaScript. The Java language was designed from the ground up to be run on the server side. Java isn't as easy to pick up as JavaScript, but the resulting programs are fast enough to handle requests from thousands of users at once. Popular Java web frameworks include Spring and Java Server Faces. Python is a highly flexible programming language that's easy to learn and use. Python is also very popular for data analysis. Popular Python web frameworks include Django and Flask. C# was originally developed by Microsoft as an alternative to Java. If you're going to be working in the Microsoft ecosystem, you're going to want to learn C#. Popular C# web frameworks include ASP.NET MVC and ASP.NET Core. The web framework then coordinates the rest of the process of handling the request. Code written by the backend developer uses ORM, short for Object-Relational Mapping, to connect to a database and retrieve data that will be used in the finished web page. Programming languages and web frameworks represent data as objects, and the ORM library is responsible for converting database records to objects. Most databases use a separate language called SQL, short for Structured Query Language, to retrieve data. The ORM library automatically writes most of the SQL queries to retrieve the needed data. Sometimes, though, a query is so complex that the ORM library can't handle it. Backend developers need to know SQL so they can write their own queries in these situations. Once the data has been retrieved, the backend developer needs to insert it in the pages that were designed by the front-end developers. Web pages are written using HTML, short for HyperText Markup language, and a backend developer needs to know enough HTML to be able to update the page. Or if you're maintaining an API, the server might send a response that's meant for use by a program other than a browser. The most common formats for API responses are JSON, which stands for JavaScript Object Notation, and XML, which stands for Extensible Markup Language. A backend developer needs to be able to convert data to JSON or XML for the server to respond with. Once code has been written to carry out all these steps for a request, the backend developer's work is done. The web framework will automatically deliver the completed response to the web server, and the web server will respond to the user's browser. If the backend developer has written their code carefully and cleanly, avoiding slow or inefficient operations, then this whole request and response process usually takes less than a second. Successful backend developers rely on other tools besides their programming language and web framework. You'll need to be familiar with the database software itself so you can create the tables and columns that will hold user data. Fortunately, most databases work similarly, and the ORM library will handle most of the work of managing the database for you. Popular database software includes MySQL and SQL Server, as well as PostgreSQL. You'll need to have one version of your code running on your web server, and another version on your own computer while you work on new features. Version control software can help you manage these different versions of your code. Popular version control software includes Git and Subversion. You'll also need computers to run your finished web app. Gone are the days when most companies ran giant server computers in their own buildings. Nowadays, most apps are hosted on cloud hosting platforms, which can deploy copies of your app to as many or as few servers as you need. Popular cloud hosting platforms include Amazon Web Services, Heroku, and Google Cloud Platform. Learning new technology is hard, and one of the most difficult parts is figuring out what you need to know. I'm a teacher at Treehouse, an online school where you learn at your own pace. If you're new to software development, Treehouse is the best place for you to learn.
Pretty cool! Our friends at Treehouse showed us a lot about back-end development. Until next time, guys!